Okay, let's do some more trig. Oop, not an example. I didn't mean to write that. I meant to write 5.5.29. It's not, it's out of the back of the book. Let's do another trig because that's always where you guys have questions. Well, not always, but typically where you guys have questions. So if I have x and we've got cosecant x squared, cotangent x squared dx. Ooh. Okay. Think about your toolbox. What do you know? First of all, go for some inside craziness. Right? I've got this as an x squared on the inside. What do you know about cosecant, cotangent? Yes, that's why we memorize those. Cosecant, cotangent is just cosecant, right? That's an antiderivative that we know. I've got this extra x hanging out, but no problem because it's 1 degree less. So if u here is x squared, du is 2x dx. If I've got this x dx that I'm subbing out, I've got to get rid of that 1/2. Dividing both sides by 2, let me write that out since we're still learning. Divide both sides by 2. I've got a 1/2 du is equal to that x dx. So toss that 1/2 in front. I've got cosecant u, cotangent u, du, because that x dx, both of these pieces become this du. Keep those differentials. Keep those differentials. Now, I've got a negative 1/2 cosecant u plus c. Plug back in for the variable. Negative 1/2 cosecant x squared plus c. I'll do the trick. Yeah, it's just, and the more you do this, the better you're going to get at it. If you can recognize your trig integrals, amazing, right? Amazing. That is super helpful. Whenever you try to identify what am I subbing out, what makes this happen, all right? Okay, let's try another one. I call this one a fancy u sub. I am integrating x over the square root of x plus 1 dx. There is no quotient rule, right? Not when we integrate. This is not a monomial. I've got 2 terms underneath this radical. You cannot split that up. It just is what it is. So remember when we said it's the inside function or the crazy thing? That is what's happening. It's in the denominator. And it's kind of crazy. But what's the, what's the derivative of x plus 1? 1 dx, right? So I'm just going to write as dx because you don't need to have that. So whenever I go to integrate this, I've got this square root of u, and du and dx switch out. But when you make the conversion, you have to make the conversion of everything. With a u sub, everything has to be in terms of u. Everything has to be in terms of u. So, no problem. Look at how we can solve this little linear equation. If you subtract 1 from both sides, x is now equal to u minus 1. And x can be replaced with u minus 1. Oh, now we got a monomial in that denominator. Do you see that? So that's what we've been practicing. So as soon as you have that monomial in the denominator, I can split this up. U divided by u to the 1/2 minus 1 divided by u to the 1/2 du. You see that? Divide that up. Okay, I'm going to scoot this up a little bit. So here we are with these like bases. This is the same thing as 2 over 2. And you want to get it to where we're just algebra at this point. So I'm going to integrate here u to the 1/2 minus u to the negative 1/2 du. Right? Because this, I want to make it into a polynomial. Like bases, 2 minus 1, when you subtract those, it's bigger on top. Here, I'm going to take this and move it to the top so that I can work with it in terms of a polynomial. Add 1 to both of these exponents, which if you get a common denominator, that's 2 over 2. So now I have u to the 3/2 with a 2/3 in front, minus u to the 1/2 and bring that 2 in front, like 2 over 1, plus c. Now just sub back in, because if you start with an x, remember, you have to end with an x. So just sub that back in, and you're good to go. 2/3 times x plus 1 to the 3/2 minus 2 times x plus 1 to the 1/2. Right? Anytime you can break that down to a polynomial, you need to do it. The big takeaway from this problem is that anytime you use sub, if you change the variable, everything has to be the new variable. You cannot leave a whole standout x in there. That doesn't make sense. Your differential is in terms of u, so every single term has to be u. All right? Okay. All right, check this out. Here is example. I'm going to just call it smiley face because I want you to see what's going on here. Cosine 5x dx. All right? What's my inside part? Will be that 5x, right? So u here is equal to a 5x. du is 5 dx. Well, the only thing I have to sub out here is the dx, so I've got to take this 1/5 and divide it to the other side. So my 1/5 du is equal to dx. So look what I've got. 1/5 integral here of the cosine of u du. So the antiderivative of cosine is sine. So I've got sine u plus c, and then sub it back in. So 1/5 sine 5x plus c. Now let me share something with you, ladies and gentlemen. Anytime you do a u sub and you only have a number with a dx, don't do a u sub. Don't do a u sub. If it's just a number here on these inside, think about reverse chain rule. If I reverse chain this, right? Chain says you multiply by the derivative of the inside. All you got to do is just divide by the derivative of the inside. You can go directly from here when it's just a number. Put the 1/5 in front, keeping the guts, right? Keep the guts. That's a chain rule. If I'm looking at this, I've got cosine and will give me a sine of 5x. You can only do this when it is a number. Okay? You can only do this when it's a number. If you were going to do a du over here and it has a variable in it, you can't do that. It's not going to work. Okay? Just if it's a number. Your book doesn't even give you an example like this. They say, hey, here's the chart of what it is that you're doing. Now you know. And this is, I wanted to do this example because I wanted to prove why you know. So anytime you have this ax in here, you keep that ax and it's 1 over that. Every time. Secant squared tangent, secant tangent is secant. Anytime you're working at this, if there is just a number, let me write it. Just a number. So just a number. That's whenever you can do the 1 over that number. All right? Okay, so don't do a u sub for something like this. Just goes directly to the answer. There's no need. You can cut out the middleman here. Just go right to that answer. Okay, cool. Now we've done indefinite. Ooh, what do you think we get to do next? Let's see.